Okay, this video is how to write balanced formulas for ionic compounds. Ionic compounds have many ions in a three-dimensional lattice, and the formulas are a simple relationship between the number of cations and anions in each of them. So this is sodium chloride, the sort of salt that you put on your fish and chips, and it's a 3D lattice full of sodium ions and chlorine ions. As you can see, for every one sodium there's pretty much one chlorine, so it's a one-to-one relationship for this. In reality they make these crystals, so you can make a crystal in theory as big as you like, but the salt that we put in our fish and chips is kind of broken up. These crystals are broken up. So as you can see, it's a 1 for every one sodium, there's one chlorine in the lattice. Same with sodium fluoride. This one sodium is surrounded by the fluorine, but then the fluorine would also be surrounded by sodium. So overall, for every one fluorine, there would be one sodium on average. Same with lithium fluoride, one lithium for every one fluorine. Lithium chloride, so there are different ways of showing the lattices and the actual crystals. It's one-to-one for sodium and iodine, unusual crystals. For this one, how many chlorine ions for every copper ion? So you can see a copper ion here, and there's two chlorine ions. One copper, two chlorine. One copper, two chlorine. So the formula represents this. The little 2 means that there's 2. They're unusual crystals. So if you pause this, you can have a look at this video on YouTube about growing crystals. Okay, so our ions, we need to be familiar with all the cations, positive ions, and all our anions, negative ions. So as you remember from previous video, these have lost electrons and these have gained them. These are complex ions, these ones, so this is a little group where the phosphorus and 4 oxygen have got together in a little group, and that whole little group has gained 3 electrons. That's why you need to keep the brackets around the little groups. Phosphate, from a previous video, you'll remember this means phosphorus with oxygen attached to it. So we also have these complex ions. So for writing a formula, the formula is a summary, as we looked at, of the number of each ion in a compound. So sodium chloride means that for every one sodium, you can write a 1 here for each of them, or if there's only one, you can leave them off. So I've written the 1s on these ones. So lithium is a 1-to-1, magnesium is a 1-to-1. So the steps. First thing, you need to find your symbols. So if you're writing a potassium oxide formula, you need to find your symbol for potassium and the charge, and your symbol for oxygen and the charge, and write them down so you can work out how to balance it. If they're complex ions, write the ions in brackets, so how many there are in here, and then the charge for this little group on the outside. So you've got your ions, and then you need to balance the number of positive charges and negative charges in the formula so that you have the same number of positives and negatives. And that's what these numbers down the bottom are, to balance the numbers. So that means you've got 2 potassium and 1 oxygen in the formula. When you write these formulas, you don't show the charges. The charges are hidden when you actually write the balanced formula. So let's have a practice. So we're going to do copper chloride, the formula for copper chloride. So you find the ions, Cu2 plus and Cl1 minus. So the thing is, you need to balance the charges so that you have the same charges. So each copper ion is a charge of 2 plus, so you need 2 minus. And to get 2 minuses, you have to have 2 chlorine ions. So we're balancing the number of charges. So once, to show that you've got 2 chlorine ions, we put a little 2 down the bottom. And we only need 1 copper ion, so we only have 1. You can put that on or leave it off. You notice that the charges, we don't write the charges, the 2 plus and the 1 minus up here. You just keep them in your head. So the formula for copper chloride is CuCl2. This is a formula, calcium fluoride. How many fluoride ions for each calcium? So there's 2 fluoride ions, so you can tell because of the number 2. So why do we have 2? If we've got the ions, it's 2 plus and 1 minus. So in order to have the same number of positives as negatives, you need 2 of these to balance the 2 positives. You need 2 fluorine ions for every one of those. So to write the formula, you leave the charges off. So write CAF, leave the charges off, and then just put how many you need. You can write the 1 if you want. I need 1 of those for every 2 of those, so that I have 2 positives and 2 negatives. Okay, sodium chloride. I've left the formula, the numbers off here. It's Na1, Cl1, which means for every 1 sodium ion, there's 1 chlorine ion. So calcium nitride, what does that mean? 3 calcium ions and 2 nitrogen ions. So let's see why we had that. Calcium ions are 2 positive and nitrogen nitride ions are 3 negative. So you need 3 of these to get 6 positives and 2 of those to get 6 negatives. So the way of knowing that you needed 6 is because if you've got 2 plus and 3 minus, the number that 2 and 3 both go into is 6. So 6 is going to balance. So then you just need to know how many of those do I need to have 6, and how many of these would I have to have 6. Okay? So then you've got the formula all together. 3 of those and 2 of those. Okay, this is a complex one, copper sulfate. You can see here it's 1 copper, and then this sulfate, you look at the brackets, there's nothing here, it could be a 1, so it's 1 sulfate to every 1 copper. Okay, if we were writing it from scratch, we've got the sulfate ion is 2 negatives. This means there's 1 sulfur for every 4 oxygen, and then this entire sulfur and 4 oxygen collects 2 electrons. So lead hydroxide means that we've got 2 hydroxide ions and 1 lead. If there's nothing written, it means 1. So the reason that we have 2 is because each lead is 2 plus and each of these is 1 minus. So you need 2 of these to have 2 minuses. Okay. So zinc, we want 3 of them. This formula is saying we have 3 zinc and 2 phosphate. Why did we have to have 3 zinc? Because zinc is a 2 plus charge and phosphate is a 3 negative charge. So we want to have the same number of positives as negatives. So 2 and 3 both go into 6. So we need 6 positives, which means we need 3 of those to get 6 positives, and we need 2 of these to get 6 negatives. So if you get the formula, the ions, and then work out how many of those ions do I need so that I have the same number of positives as negatives. Okay, so do these ones. 1 magnesium ion has 2 plus, so 2 chlorine ions are needed to balance it. Okay, so I haven't written out the 2 chlorine ions here, just gone straight to the formula. Leave off the charges and put how many you need of each. Alright, pause it, see if you can go through this one. So, we've got 1 plus, 2 minus, we need 2 of these so that we have 2 positives. So 2 of these for every 1 of those. Have a go at these, pause it, have a go. Okay, if this has got 2 positives and this has got 2 negatives, you just need 1 of each and it's balanced. This is 2 negative, this is 1 positive, so you're going to have 2 of these to get 2 positives, 2 of these. Make sure you're writing the numbers for how many you need down the bottom, and you're putting the charges up high. Got 2 positives, each of these is 1 negative, so we're going to need 2 of those. Each of these is 3 positive, each of these is only 1 negative, so we're going to need 3 of these to get 3 negatives. 3 of those. Each of these, 1 positive, 1 negative, we only need 1 of each. 1 of each. You can put the 1s in if you want to. 1 here, 1 here. Alright, in the groups, exactly the same idea, just keep this in a little group and treat the whole thing as a 2 minus, you know, like O2 minus. Just treat the whole thing together. So each sodium has 1 positive, each of these 2 negatives, so you're going to need 2 sodiums. 1 negative, 1 positive, 1 negative, just need 1 of each. Sorry, it's written further down. 2 positives, each of these is 1 negative, this should be in brackets, so I need 2 of those. 2 positives, 2 negatives, you just need 1 of each. 1 positive, 1 negative, you just need 1 of each. 1 positive, 2 negatives. We need 2 of these to get 2 positives. 2 of these. Notice that there's no charges. Don't write the charges on your formula. 2 positives. So we need 2 negatives. We need 2 of these. 1 positive. We need to put brackets around this. So we need 2 of those to get 2 positives. Quick way of working out the number of ions is to cross the numbers over. So you've got 3 positives and 2 negatives. If you take the 3 on the other side of the brackets down the bottom of the sulfate and the 2 on the other side right across with the aluminium, so that you'll end up with 2 aluminium and 3 sulfate. So a quick way of doing it is to cross multiply. This doesn't work if they're the same number, so like if that's 2 minus and 2 positive, in that case you just need 1 of each. Okay, so it works. It's a quick way of kind of just checking. Have a go at these ones. Write down the names. And the formulas. Pause it, have a go at these ones. So first one, got 1, but you have to find the ions, 1 positive, 1 negative, potassium bromide, 1 of each. 2 positives, 2 negatives, you just need 1 of each. 2 positives, 1 negative, you need 2 of these to have 2 negatives. 2 negatives, you need 2 of those to have 2 positives. 2 positives, you'll need 2 of these to have 2 negatives. 2 positives, 2 negatives, you just need 1 of each. I should really have these in brackets, these complex ones. 2 positives, 1 negative, you need 2 hydroxides. Okay, a quick one, you can cross it over, put this in brackets. The 3 can go over here, the 2 can go over there. So basically you need 6 positives and 6 negatives to have the same number. You need 2 of those to have 2 positives. You need 2 of these to have 2 negatives. You just need 1 of each. You need 2 iodines to have 2 negatives to balance the 2 positives. Okay.